Okay, in the last lesson, I was talking about the introduction to waves and basic properties of waves, and I'm trying to draw pictures of waves moving, which was kind of difficult to do when you're drawing on a whiteboard. So now I'm going to show you a simulation of moving waves before we come back to writing down the equation of a wave. That's really what we're going to do next. So moving to a simulation of a wave, I put a wave simulator on Moodle. Currently, it's beneath Monday 928 class, but it'll actually fall down below Wednesday's class because that's when I refer to it when that shows up. So you can just go in and you can access this anytime, and it might be useful when we're doing homework questions, when we're talking about the equations of a wave, to actually go ahead and use this simulator. Right now we don't know the equation of a wave, but we're going to use it just to make sure you understand the images I was trying to explain last time. So you can just click on it, and you actually have to save. It won't run right away. You have to save it to your desktop. It is a JavaScript applet. And if your computer is not able to run JavaScript, if it doesn't have that enabled, it might be a problem. You can let me know and I can try to find some other way for you to simulate waves. I'm not entirely sure how, but it just works automatically on my computer. If I just saved it to my desktop, and so now I'm just going to go ahead and click on it to open it. Oops, and it opened up in a different window. Hopefully you can see it here. There's two waves and the sum of the two waves. I'm going to go ahead at the bottom here and turn off the sum, turn off the second wave, and just have one wave. Here's the equation of the waves. Don't worry about the equations because that's what we haven't talked about yet. But this is a snapshot in time of the wave, right? It's a snapshot in time because this is a spatial, this is the amplitude, or this is where amplitude is used in a different way than I use amplitude. I would say this is the displacement from equilibrium, whereas the amplitude is the maximum displacement from equilibrium. But amplitude is interchangeably used to just mean the displacement at any time from equilibrium. But I would call this maybe y, or sometimes it's just called psi, as in a function, some arbitrary function psi of x. This is x, this is in space, because we're talking about one-dimensional waves, waves that just are moving in one dimension. Then we're talking about that one dimension being along the x-axis. There's no loss of generality if we just talk about it being along the x-axis. So this is a snapshot in time. If I want time to move forward, I'm going to hit play, and ooh boy, oh boy, isn't that exciting. There you go, wave simulator. So this is a wave that is now moving, right? And so this is a continuous wave. We discussed that. This is a continuous wave that is moving, and yeah, it's moving slow. We could change these properties to make it move faster. Okay, so I just changed the parameters a little bit just to make a wave that moves faster. Okay, so we can change the parameters up here, which we'll learn later about what plays a part in the wave's speed versus the wavelength, etc. But there you go, there's a moving wave. So we talked about the superposition of two waves. So let's say I have two waves here. And again, this is a snapshot in time. They're stopped in time. And I can see the superposition. I can add them up just by clicking the sum button here. I can turn off the red and the blue so you can see the sum is the black. Turn on the red and the blue and show that the sum of the red and the blue is the black. And we'll show how to do sums of waves mathematically. I had also talked about, okay, so sorry, superposition. Let's move them through time. Start the clock going. It's a little hard to see what's going on. Let's just look at the blue wave first of all. The blue wave is traveling to the right. The red wave is traveling to the left at a slightly different speed. And the sum, look at what the sum does. The sum is actually traveling to the left, yeah, it's doing whatever it's doing. Okay, so there's the sum. Now what about, we talked about a standing wave. A standing wave has a special property that the sum doesn't go anywhere. And the actual way to do that is to make the wave that moves to the right and the wave that moves to the left the exact same wave. Let's see if I can do that. And go ahead. Okay, so there's the two waves. Let's look at what happens to the sum. Look at the sum wave. Look at a peak of the sum. A peak of the sum doesn't go anywhere. So this is what's called a standing wave. And yeah, it gets bigger and smaller and bigger and smaller but it goes from a maximum, a positive maximum to a negative maximum, right? The amplitude. But there are antinodes where you have the maxima, and the nodes where it never changes, right? This wave is not moving through space. It is a standing wave. So those are just some pictures of waves. You can come in and mess with that. But what we're going to do next is write down the equations of some waves, and then that'll help us understand these pictures.